Our summary for today: in this lesson we solve story opportunities, more word problems, that involve maximizing or minimizing a quadratic equation. Maximizing and minimizing, we'll see those words today. Okay, number one, have a look at our old friend called graph A, whose equation is y equals x squared plus 5x minus 6. We've seen this graph a couple of times. In order to find the x-coordinate of the vertex, so remember the vertex is our fancy name for the either highest or lowest point on a parabola. So this guy right here is the vertex. So in order to find the x-coordinate of that guy, we would have to take the two x-intercepts and do what with them? Looking for a word as opposed to like a formula at this moment. Yeah, we average those guys, right? We know that the vertex is right halfway in between the x-intercepts. So we find the x-coordinate by averaging the x-intercepts. So that's kind of a pain because finding x-intercepts is quite challenging usually. In this case, it means solving this equation. Remember, to find x-intercepts, the y becomes 0. So this guy turns out it factors. You could do the 2 by 2 box method and you'll get the answer. Let's see, what do we get here? X plus 6 and x minus 1. Again, omitting a lot of work. That's the factored version. And then set each of the pieces equal to 0, and we get x equals -6 or x equals 1, which agrees with the picture here. But if it didn't factor, then we got to use the quadratic formula, and we saw that in the last class too. Even worse than having to do all of the work of the quadratic formula to find the x-intercepts so that we can average them is that there are plenty of parabolas that don't have any x-intercepts, right? Take that parabola and move it up, I don't know, 20 units, and it won't hit the x-axis at all, right? Does it still have a vertex? If you take that thing and shove it up 20 units, it still has a vertex. But we're powerless to find where that vertex is if it doesn't have x-intercepts, because our only way to find the vertex at this moment is to average the x-intercepts. So let's average the x-intercepts here. We'll get our answer, and then we'll see a new tool that will be a much easier way to find the x-coordinate of the vertex, regardless of whether it has x-intercepts or not. So in this case, we're averaging -6 and 1, the two purple dots. And remember, to average two numbers, you add them and divide by 2. So we get -5/2, or -2.5. Everyone willing to buy? -2.5 is the x-coordinate of the vertex. Okay, so number 2. Turns out there's an easy formula to find the vertex of any parabola. For the quadratic equation, y equals ax squared plus bx plus c, the x-coordinate of the vertex, which is exactly what we just found by averaging x-intercepts, is given by this much simpler formula, the vertex formula, x equals -b/2a. So highlight it, put some stars around it, circle it, do something. That's an important formula for us today. So let's give it a shot. According to our fancy new formula, the x-coordinate of the vertex for this guy is supposed to do -b. Negative what on top? How much is b in this particular? B is the 5, right? Same a, b, and c as before. Divided by 2 times a. How much is a? Is 1. Notice that this formula doesn't involve c. So it makes no difference, that -6. It just doesn't come into play. And what do we get? We get -5/2, which is exactly what we got over here. Yeah? And the nice thing about that -5/2 is we didn't have to find x-intercepts and then average them, which is usually a lot of work. We just need the equation. Okay. And in order to find, so that's just the x. And in order to find the y, this is the same old process. We just have to take that x value and substitute it in for all of the x's and then just calculate, right? So both of those x's would become -5/2. And then we would crunch the numbers together and we would find y. I think that's at the bottom of the screen here. Both x's highlight them. X and X both become -2.5. And then we just do arithmetic. And we get the Y coordinate is -12.25. Just typing it into the calculator. Does that look reasonable according to the picture? This guy here turned out to be at -2.5, comma, -12.25. That agrees with the picture, right? Okay, so that's our fancy new vertex formula, just -b over 2a. And I'll point out that that is actually part of the more complicated quadratic formula. So remember, the quadratic formula is this -b plus or minus square root of a bunch of stuff divided by 2a. Yes? Do you see this yellow highlighted thing in there? There it is. Just ignoring everything after the plus or minus. The quadratic formula contains this new vertex formula. Okay, so I said that there were going to be word problems today, and you'll find them in the activity. We're not going to do any here, but I just want to point out number 5 here. It's often useful to be able to determine the smallest and largest value a quantity can assume. For example, companies try to minimize costs or maximize profits, that is finding something small or something big. If you see the word maximum or minimum or biggest or smallest or highest or lowest or any number of synonyms for those words, there is a very good chance that the answer is the vertex. So in the activity today and in tonight's homework, you are going to be looking for any words like these words here. And what that just means to you is, oh, this problem is asking me to find the vertex. So if it says, find when the school enrollment is at a maximum, that's really just saying, oh, find the vertex. If it says, find when the speed of a car is as low as it will be, oh, great, that's just the vertex, right? The problem is not going to be explicit and say find the vertex, but you need to translate all of those words to, oh, this is just asking for the vertex. Okay, number 6, we began graphing parabolas a couple of classes ago. Now that we have an easy way to find the vertex and one that works even when there are no x-intercepts, we can graph certain kinds of parabolas we couldn't before. So the last one in our demo is here on the next page. A new and improved 6-step process summarizing how to graph parabolas. Let's see if we can run through this process down here in 7. So there's our equation. The goal is to draw the parabola. Just like before, we're looking for 5 points. Oftentimes 5 points are the y-intercept, maybe 2 x-intercepts, the vertex, and then a symmetric point of the y-intercept. We're still looking for those points, but now some of them are going to be a little messier than they were before. Okay, first step is, does the parabola open up or down? Let's give it a shot. Does this parabola open up or down? 1 vote for down. A few more votes for down. Nobody wants to say up. That 4 is positive. Isn't that what makes the parabola open up? Is a positive 4 in the front? Yep, we got some buy-in there. So is it up or down? But it's positive 4. So someone needs to convince Nick it's positive 4. Why are we saying down? Yeah, it's not in our standard form, right? Usually the first term is the x squared term. So we have to hunt around to find that thing. That's the thing that determines whether it opens up or down. Is the number in front of x squared positive or negative? It's -3. So this guy opens downward. So here's our justification. Say opens down. Since a is what number? -3, and that is a negative number. So that's our justification. Okay, next thing we're after is the y-intercept. In order to find the y-intercept, which we did way back on class number 3 or something, what do? Make x 0. So we get y equals 4 plus 2 times 0 minus 3 times 0 squared. And that is just 4. Let's write both coordinates of the y-intercept. What comma what? 0, 4. Okay, and we can go ahead and plot that point. That's here. The other day, when we first started graphing parabolas, our next step was to find the x-intercepts. That was the hardest step. We're not going to do that first right now. Now we're going to find the vertex, because finding the vertex with our new formula is quite easy. So, vertex. This is my notation for the x-coordinate of the vertex. What's our new formula with letters in it? Negative b over 2a, that's our formula, equals negative, how much is b? 2 divided by 2 times, how much is a? It's negative 3. Again, don't get deceived. That 4, just because it's first, doesn't make it a. Okay, and so this guy reduces. 2 negatives make a positive. That is not right. And the 2's cross off, so 1/3. Okay, so that is the x-coordinate of the vertex. Now we're going to find the y-coordinate of that vertex. So here we go. Y vertex equals. I've only got one equation up here that says y equals. It's the very top one. It's the first equation. What are we changing those x's into? 1/3. So let's change them both into 1/3. 4 plus 2 times 1/3. That's the x-coordinate of the vertex. We just found it. Minus 3 times 1/3 squared. Okay, so we're going to crunch all this together. Let's see if we can do this without a calculator. This equals 4 plus 2 times 1/3 is 2/3, multiplying across, minus. Okay, so we'll do this on the side here. Negative 3 times 1/3 squared. All right, so 1/3 squared is really 1/9. And then the 3's cancel, right, where 3 goes into 9 evenly. So we just get negative 1/3. Is that all right? Crossing off the 3 and the 9. So that goes right over here. Maybe it's better to just make it positive. So we didn't reduce 1/9 to 1/3. We canceled. This 3 and this 9 became a 1 and a 3. And so our answer was just 1/3. Okay, let's finish our calculation here. 4 plus 2/3 minus 1/3, that's really 4 plus 1/3, right? So 4 1/3 is fine. Oftentimes we write things as improper fractions. I think that's 13/3, all right? Okay, so let's say this. When we did parabolas the other day, I kept all of the numbers very friendly. I don't think there was a single fraction in any of the calculations. Sometimes there were fractions in the equations, but you could get rid of them by multiplying both sides by the right thing. So today's parabolas are going to be less friendly. So I know we're not thrilled with fractions, but we got to deal with them. Okay, so I think we have our vertex. Let's write down both coordinates here. The vertex is, what was the x coordinate? 1/3. And we just did all that work to find the y coordinate, 13/3. Okay, and we can plot that point too. 1/3 and then 4 1/3. 1/3, 4 1/3. Pretty darn close to the y-intercept. So that's the highest point right up there. Any questions so far? Okay, so now, after we got the vertex, what's the next big piece of this puzzle? X-intercepts. We have not found the X-intercepts yet. Now here's the good news. The bad news and then good news. The bad news is today the X-intercepts could be quite messy. They could be irrational numbers, decimals that go forever without repeating. But the good news is some of our parabolas today aren't going to have any X-intercepts. And if we figure out that a parabola has no X-intercepts, then we don't need to spend any time trying to find them. All right? Again, on day one of parabolas, I gave you only parabolas that had X-intercepts, but today they don't need to have them anymore, now that we have the vertex formula. So let's think about this. This parabola opened which way? Opened down. And so I'm just imagining, I'm not drawing it yet, but I'm imagining a downward parabola, and the vertex is up here. Is this parabola going to hit the x-axis or not? It will, right? Because it's got to do something like that. But if this had been an upwards parabola with a vertex here, would that parabola hit the x-axis? No, because we know the vertex is the highest or lowest, right? So if it were this kind of parabola, we'd say, hey, no x-intercepts. We've done our analysis. We don't need to spend any time trying to find x-intercepts, which is quite nice because finding the x-intercepts is the hardest part of this parabola drawing process, right? Now this is spelled out up above here in step 4. There will be no x-intercepts if the vertex is above the x-axis like we had, and the parabola opens up, which was the second thing we drew, but it's not ours, right? Likewise, you will have no x-intercepts if the vertex is below the x-axis and the parabola opens down, right? It'll never get up to the x-axis. Otherwise, the vertex will either be on the x-axis or you'll have 2 x-intercepts, and that's what we have now. Okay, so we've done our analysis. Turns out we do have x-intercepts, so we have to find them. You might spend a couple of minutes trying to factor this thing right here. Oh, I'm gonna take one step back. Again, from class number 3 or so, how do we find x-intercepts of anything? Make the y 0. So that's our starting point. So we're going to copy that equation, but change the y to 0. Okay, so you could spend a few minutes maybe trying the box method to see if this thing factors. I'm pretty sure this particular one doesn't. So if it doesn't factor, what's our go-to technique for solving this equation? What's that? Quadratic formula. That's all we have. So we're going to do the quadratic formula here. X equals, let me copy all of this and then we'll change the letters to numbers. Okay, negative b becomes negative what? 2 plus or minus square root of b squared becomes what squared? 2 squared minus 4 times a times c. A is negative 3, c is 4. If it's messing you up to have that thing not in standard form, then rewrite it so that the x squared is first, and then the x, and then the constant. All this is divided by 2 times a, which is 2 times -3. Really important to not put the 4 there. Okay, so now it'll start to look better. -2 plus or minus square root of 2 squared becomes 4. Minus minus becomes plus. Now I'm just multiplying positive numbers. 4 times 3 times 4. I think that's 48. All divided by -6. So we go -2 plus or minus the square root of 52 divided by -6. Okay, so that's the exact answer. On the quest, I'm going to expect that you'll be able to simplify this thing. Because what nice number goes into 52? Which one? 4 goes in. But on the parabola graph, having this guy reduced as a simpler radical doesn't do us any favors. Ultimately, we need to get a decimal, right? If we're going to graph a point, we need decimals. And so since we're going to a calculator at some point anyway, might as well just go there now instead of trying to get to a simpler radical, but then ultimately the calculator anyway. So very carefully, we'll type this thing into the calculator. Okay, so we're doing -2 plus the square root of 52. I like to do this in 2 steps. I hit enter there and then divide by -6. So there's one of our X-intercepts. This one said round to the nearest what? In the directions? 100th? Okay, so what is this? -0.87, that's one of our answers. Okay, and then we'll do the same thing, but -2 minus root 52. And divide by the -6. There's our second answer. So we said -0.87 and 1.5, what? 4? We'll round that 3 up. Okay, I'm a big fan of writing both coordinates of any point we're interested in. These were X-intercepts. Remember the very first thing that we did was let y equal 0. So where does the 0 go in my points? X or y? 0 is the y, right? 0, 0, and then these two numbers, -0.87 and 1.54. Okay, so now we're just approximating these points on the graph, so plotting those 2 points. -0.870 and then 1.540. And I guess there's just one point that we're missing. I see 4 points so far, but remember our standard is 5. And so the only point that we're missing is the symmetric one to which one? Yeah, the one at 4, the Y-intercept, right? So let's just find the symmetric point there. Remember the x coordinate was at 1/3 comma something. Oops. So to get from the y-axis to the vertex, we had to go 1/3 to the right. So to get to the symmetric point of that black dot, we need to go another 1/3 to the right. So I'm ready to put a dot right here and say that the coordinates of this guy are 2/3 comma 4. Combine that. from the y-axis to the vertex, and then again that same distance. And then once you got your 5 points, drawing something smooth and curvy, make sure it extends all the way to the bottom of the page. This one's going to be fairly thin, and therefore hard for me to draw. Let's try it again. Close enough. Okay, these guys are not easy, not easy. This homework is not due next time. In fact, there's no homework due next time. We're just studying for the quest. For this homework will be due not even on Tuesday. This homework will be due a week from Thursday. So we'll have plenty of time to practice this. But right now the priority is the quest. Sorry for going over today. These ones will be due, after Thanksgiving actually.